Thank you so much for the introduction. So yeah, my name is Ruben Telstra. I'm gonna talk about the limits of Python, and I want to say right now that it's not about the limits of Python, of that's bad or like Rust or another language is better. It's more about that my personal experience during this project, how I discovered what I went through, and how my proof of concept went to an MVP slash an early release variant, and how this eventually like became more of a product by itself. Um, so yeah, then I will start. Yeah, I was already good introduced, but a little bit about myself. So yeah, I'm 24 years old. I work almost 5 years at the company right now. So and I'm currently also a full-time student at Hanze. I do volunteering for Rotary and just started and Stichting. And I contribute to LibreChat. I don't know if somebody knows about that, but I'm one of the main contributors to LibreChat. It's like an AI front, like open chat. Okay. So the real problem. The real problem starts with that clinical studies produce data. When they need to submit this to the authorities that needs to validate if a medication is allowed to be used continuously, then they need to prove this by a medical study trial. This study produces a lot of data, and this data needs to be formatted in a special way. And this special way, it's called SDTM. It's a CDISC standard that's widely used. There is also an alternative, but I'm mainly going to talk about this standard. And this standard is, well standardized, sorry. And it's how CSVs, or most studies produce CSV data because it's coming from a form that you fill in manually, and then they produce a database record, and then they need to transform this to their desired output. And that's then an FDA compliancy that you need to use to be able to submit this for the next step or be able to publish the drug. So why this is a problem? Because currently they program most of the time. So they send off the data to a third party. The third party will use a SAS language, and the SAS language is a proprietary language that you need to pay to be able to use it. And when you then transform the data, you get the export data from it, and from this export you then submit to the FDA, and if there's something wrong with the data, you need to go back to your study, maybe alter it or open a protocol to be able to change it, and then submit it to the programmers again to be able to submit it again. So it's a whole life cycle process that you need to go through. And I was thinking when I did my minor, can the data manager not do it by himself instead of a programmer needs to do it? So he just selects a column from the left side and maps it to the right side, and then he just maps it himself or herself, themselves. And then you speed up the whole process because there's no middle person anymore. So because you know your data, because you set up your study, so most of the people, so you know the data. And you also know the standards because your format is based from the standard, so you're the best person, I would say, to be able to map the data. So then the real problem really started in what are the requirements that needs to be solved that they can use the software, the solution, in their ecosystem. So it needs to be offline, so it cannot connect or need to retrieve or needs to be able to get data because it's sensitive data. So the solution needs to be working offline. Then the people who are using the tool are non-programmers, so it should not be used for scripting or some Python scripts or some other scripting ways that they need to touch something to be able to alter the data or like map the data and then transform the data. And there needs to be an explicit output, so that's an XPT, that's a legacy format, that's IBM based format that needs to be, it's a fixed length format structure that needs to be submitted as a binary file to the FDA. So it's a really old way of submitting data. The file cannot exceed 4 gigabytes, then it needs to be split. And then you have trust. So because you need to validate and also know that what you're producing, it's not altered, because you're not allowed to alter data, you're only allowed to transform the data. And that means that if there's a male or female and it says as a male variant or female full length, the FDA is expecting an M or an F in capital letters. So, but if you write an X and that's not one of the allowed characters, then you need to write unknown or another approved, accepted terminology or value. So that's the validation / transformation part. So there's a few steps that needs to be done before you can produce a tool or a software to be able to do this properly. So I started first with the initial prototype with ingesting data. So ingesting CSV and then lazy fuzzy map the columns, because most of the time the columns represent almost the same column names as the STD or the standard from CDIS. So you can get maybe 60 or 70% comparison, and then you get then the person can then say yes, it's true or it's not true, and then the person selects the real column, and then validates this against the data set that it's expecting values, and then you can export the data. So this is in very easy steps how this could be done. So then obvious Python was my first choice, because I could fastly program the application by itself. There were already packages available to do the export to SAS. So there were other companies already, or pharmaceutical companies that already produced an exporter from Python to be able to use, produce the XPT files that I needed. And because it's a not too complex language to easily change and alter the tool, and you can do fast iteration. So that was why I chose Python to start first with it. Then the first architecture worked. So the data loading, ingesting worked, the mapping logic worked as well, like the basic mapping, and then the GUI prototype, because currently it had only a TUI, so terminal user interface, and that's not something that you can give someone who doesn't understand the terminal, I would say. So you need a graphical user interface that someone just click around instead of selecting with the arrows on the keyboard. So then I came back to the drawing board and tried to see what kind of frameworks, packages Python has, and no. Okay, no one. I see I have the slides wrong. Okay, yeah, I will come back to the GUI later, sorry. Then I had some performance issues with the data ingestion, but also the transformation, because I was ingesting 1 million CV, one line of 1 million rows of CVs per domain, and there were 24 domains sometimes, so you're ingesting per study a lot of rows, and that was getting very expensive on computation. So the machine gets stuck after 15 minutes of running, and then it was getting an error, so I needed to move or optimize, and so I looked into what other packages did, and they opted for Rust engine and then a Python wrapper like PolarRS. It's a Rust core engine, and it has an API endpoint for Python, so you can use Python, and then underlying the core engine is written in Rust, so you can do the heavy compilation in native language, or almost native, and then do the connection and do the interfacing on the Python level. So that was my obvious next choice. So I changed the exporter to Rust. So I created the bridge between the heavy logic, so the domain-specific logic for ingestion, for validation, for transformation, and also for exportation on the Rust level, and then had the UI, or the user interface on the Python side, because I was not sure yet how the user would need to interact with the system. And yeah, that was the main reason why I still kept it on the Python side, because it's more flexible on that end, and I was not sure yet how the APIs or how the interfaces would work. Here is a little bit of how the highest level of my export package looks like. So here we have a data set. A data set is just an data frames. So you just ingest data frames into your Rust package or in your Rust package, and then you build via your selected agency. So there are different agencies that you want to export to, and it has some different characteristics for exporting. One needs to split the data, so one cannot exceed 4 gigabytes because of limitations of the reading machines. So 4 gigabytes is the max that you can have in one file. So then you need to split the data. And for the Chinese one, you need to have duplicated languages. So for China and for English, so you need to submit twice your languages. So there were different criteria for this, and I got the inspiration from an R package that has the same characteristics. So I took inspiration from the R package and created a Rust alternative for my engine. And then circling back to the GUI. So when it was time to build the GUI, I chose Tinker, sorry, and Qt for the bindings for the front end, and then I used PyInstaller to create one single binary, because to install Python or the proper version and everything on the machines is not really the practical way to be able to distribute it easily for people. So to have it in one binary that they can just click it and it will just open without installing anything is the better way to go with people who are not that knowledgeable in software or installing. And also for installation administrators, they prefer what I talk to in one single binary instead of a whole installation script to place it there. So I went on using Python for the GUI. Then the workflow became like visible. So I started to play around with how it should be working, how it should work, what are the interfaces, what are the user interactions that somebody needs to use, what are the automations that I can create, and then what are the mechanics regarding the interfaces, because the user, you want to minimize the clicks for the user, but also give it that much freedom that they can use everything what they need to do. And that's quite hard if you are not a domain expert. So I don't know, when I started this project, I didn't know anything regarding medical trials or how the submission in its entirety went. So that's only the standard itself is a 400-page PDF document, and that's only the standard. So it's quite a lot of information that you need to go through. And of course, with AI, you can speed up the knowledge process, but verification is still better than trusting what it outputs. But you can speed up the process regarding information ingestion. So that's what I did. So I got some ideas, I drew it out, and then I implemented it. But then I came to the next problem. Then I had two code bases, one for Python and one in Rust, and I had more code in Rust than in Python, and the middleware that I needed to write to bind those together were more than the Python code in its entirety. So I was like, what if I want to change something? Then I need to rebuild mostly the between layer and also the Python. Should I move to Rust? That's a difficult question to ask. I opted for Iced because it's the most complete Rust package or framework. There are no stable versions in Rust to use for GUIs. They're only experimental. There's even a website called Are We GUI Yet? There's described almost every framework that Rust has to GUIize. But no, everything is experimental currently. Yeah, so I chose for iced because it's Elm-based, and Elm-based particular is trigger event-based. So because otherwise I need to redraw every frame on the screen, and then I'm fixed to 60 frames per second. So with the trigger base, you only change what the user sees, and then you can keep the application as fast, as native as possible. But this also comes with a downside. The architecture looked cleaner, yes. But the ecosystem became harder because the packages or frameworks are not complete. That means you need to use also native code per machine. So if you want to distribute to Linux, macOS, or Windows, you also need to write native code for certain features because it's not yet compatible with the tools. So knowing that, after I converted the tool, I was like, okay, yeah. And now I'm stuck. That's basically the outcome. But circling back to Python, I would say that I should have stayed for the GUI in Python because changing something now in the GUI is harder now than it was before. And even though updating two code bases seems a lot of work, but with the freedom of Python in the GUI, you have a lot of flexibility. And it's a really good glue to combine Rust and also Python, or like as a language, because also PolarRS has also explained this in their documentation, that it has great power for the domain-specific task and core-specific tasks, but for the flexibility for people to use, is Python more flexible and way more user-friendly. So yeah, that's also my takeout for my talk here, is that I use Python first, and I will do that again, for sure. I would still move certain parts, for example, the exporter that I wrote in Rust, because it's so heavy ingesting and also transforming data that the native experience excels for the overhead that it creates. But regarding GUIs, I would still go back to Python because of the maturity it has, and also the ecosystem that it supports. It's way bigger, has way more people in it, and it's way more mature, as I said. So this is what I sort of joke, really. Python got me the truth to the problem. Rust got me to shape the final product, plus a lot of headaches. Thank you.